era of big data. As you can see right now, it's a just era. Okay. It is expected in 2020. The total size of the data will be 50 times of the right now. Okay. In addition to the size of the data, another problem, another challenge in the big data era is the data type. So far we have dealt with, in terms of database model, we have dealt with structured data only. Even though we are using the object-oriented concept in software engineering as well as computer programming. What about the database? What did you learn in database design? You probably learned entity relationship model and relational database model. What is a relational model? It's a relation set. It's a very, very strict rule. You cannot handle even multi-valued data. You cannot handle nested data. You cannot handle even composite data. That's the reason each value, each attribute should have atomic data, something like that in normalization process, which means it's a very, very strict rule. However, nowadays we have even unstructured data or semi-structured data. What is the example of such a semi-structured data or unstructured data? So unstructured or the semi-structured data. Can be the example. Email.
Yeah.
Email is a kind of semi-structured data. Email has the format of subject line, sender, receiver, and so if you take a look at the SMTP protocol, there's a rule, there's a format, there's a data structure. But it's not like the relational database model. In the text bar, in the body, message, it's a free form kind of. But you are interested in something data in the free form, right? To detect which one is the spam one, right? So it's called the semi-structure. What else? Images. Every day you take a photo, okay? Images. Does it have the format? Yes, it has the format of what? Image itself, okay? Image format like the PNG, PPM, and GIF, JPEG. It has the format, but it does not provide the data format, data structure for information. Nowadays, there is an approach to design, to model such information in multimedia data like the MPEG-7, MPEG-21, but it's not good enough to handle such a. Some multimedia data, social network data, or email are unstructured or semi-structured data. Even they can be object-based or spatial-based data type, like the RFID or sensor data. For example, whenever you drive, your car should have the sensor in the next few years. Do you know that? So it's a pattern in the government. So each car should have the sensor for what? To alarm each other. So if you get close, it's alarm each other, and so to prevent the car accident and something like that. Where the data goes. There might be somewhere in the department of the vehicle or the vehicle or wherever transportation, they will keep such a RFID data or sensor data. Okay, that's the source of the big data also. And their characteristic is well organized in terms of the modeling and managing such a structured data and traditional data. It's very not easy actually, but relatively easy to manage such a data. Because of that, still relational database management system are most popular used data management tool. I don't think relational database will be replaced by the big data system or NoSQL database. No, I don't think so. Relational database will keep going. Okay. However, the problem of challenge of the relational traditional system will be replaced by the big data system. That's what I'm thinking. That's what the most people expect for that. However, it will be soon complex the data. So right now, for the Facebook data, social media, social network data, can we use the relational database to keep the Facebook data? You can use, but if you are using the relational database model for Facebook, what can the problem?
Too many different data types.
What can the problem?
What's the use case?
How to create relation between those data? How to create relation between this?
The relation. For example, when I post a message to the Facebook, okay, do you think it will be synced? When I post a message, can all the Facebook member can see my message? No. Actually, no. It will be available several hours later sometimes. It's unsynchronous. Okay. It's not synchronized. So in relational database, when I insert the data that committed, it will be available for everybody. It's always synchronized. There's the data consistency.
You mean also that for some things, other people, even my friends.
Sometimes you need to wait. Your friend sometimes you need to wait. Okay? It's not real time because it's a big data. So they have some distributed system. Okay? In relational database, it should be synchronized real time. But in big data system, no, we need two different management system to manage such a data. Okay? And even Nielsen should be real-time data. But don't be confused. Real-time means really real-time. No. Okay? Real-time means
Like Twitter, tweets.
it's
Like a chat,
it's a guaranteed time always. But in a reasonable time, cannot be really real time. There might be latency delay, but that delay should be expected, guaranteed, as you have in the operating system. But that real time data is everywhere. So which means not only we have the big data, but also we need to process simply fast. Okay? That's our challenge in big data era. So, what is a big data? This is a definition from the wiki. Data set with the size beyond the capability of common users of your tool to capture, curate, manage, and process the data within or tolerable elapsed time. Okay? Tolerable elapsed time. And Gartner, you know the Gartner. Gartner is the, where's the headquarters of the Gartner? It's Stanford. It's in Stanford, correct? So it's a kind of the survey, research survey group. They are sent after the survey, the research, survey the big data, okay, statistics. So in 2015, how many companies will purchase the big data system? And 2020, then they send this information to the company. Okay, that is Gartner. So Gartner says big data is a high volume, high velocity, and high variety information as that requires new forms of processing to enable enhance decision-making, whatever. So this volume, velocity, and variety, 3V, it's called the 3V, are very popular definition of the big data system. So Wiki, Gartner, so probably you can imagine what is the definition of the big data system or big data. But in addition to that, I believe for company, for example, I found it startup company. At the time, I tried to use big data system because of this one. My data is not so big. Okay? less than 1 petabyte size data. So do I need to give up the big data system? No. Sometimes I can get the benefit of the big data system. So I believe big data means it's relatively big data, which means I have this power of computer. Okay? This is just a value. I have 1 petabyte size data. So using the relational database, if I have 10,000 bucks, definitely I can implement system. But does it make my budget is large? 10,000 I cannot afford 10,000. The time you can get the benefit of big data. Okay? Whether or not I can process such an amount of the data. If you cannot process, that means you have big data. Relatively big data comparing to your resource power. Okay? At that time, you can get the benefit of such a big data. In addition to such a definition, this is a general definition, but for individual or the company, it's a kind of relatively big data. Whether or not you can afford, you can process, you can manage the data. If you cannot, at the time you can consider the big data system for your processing. So that's the big data. So first, why don't we take a look at the 3V? Okay, that's where we define the definition of the big data. First, the volume. Definitely, it's a size, right? So I don't have to mention about such a curve amount of the size along the year. Okay, everybody can yes.
This is during the year, right?
Yes.
2005 to 2007.
Yes. Don't worry about too much for the specific number. Just realize such a trend. Okay, nobody knows actually how much the size of total. Nobody knows actually. It's okay. It's just guesses, estimation. But it's true. It will be growing up. Not the linearly. It can be exponential. So it's the size of the volume. Okay. So it's not even the terabyte error, petabyte error. It's a petabyte error. Okay. For example, Twitter. Tweeters per day is 2007. It's almost less than 5 per day per person. But nowadays, if you are using the big fan of the Twitter, how many tweets a day? It's hundreds of times. Who has a retweet? Okay. Next one is a variety. Variety means how much complex the data is. Okay? The traditional data is alphanumeric data. In other words, text data. So A to Z or 0 to 9. So that's enough. Okay, and also they are well organized, well formed. So very, very strict rules are applied to organize the data, such as relational database model. However, in big data era, we have not only text numerical data, but also image, audio, video, sequence. Think about how difficult to manage such a multimedia data in relational database. They each, DBMS, IDBMS vendor, Oracle Informatics, they provide the way to manage such a data. Nobody uses. Why? Because it's very difficult. Because relational database itself is only for, not only, but almost only for alphanumeric data, text data only. Not good for multimedia data. That's the reason I'm offering multimedia database system. One of the purpose. And multi-dimensional data or array or social media data. Why social media data is so example of this one? Social use, what is the basic mechanism of the social media side?
It's with 2.0. So mean like user provide information.
User provide information. For what?
Share improvements. Sharing moments.
Sharing what?
Moments.
What?
Like what?
Personal information.
Person. Why you share the first person information? It's a connected social life. It's a social life. Even before we have the social media data, we have social life. It's not this. So I love him. I thought we interact with each other, then they met. Okay, I have a friend, and I hate this group. I love this. So you have managed your friend, and sometimes I introduce my friend to others, right? So you manage such a social life. Exactly, you can do the same thing in digital computer. That is social network, social media side. It's based on connection, connected. Okay, so when you have a user, connect, like a friend in Facebook. There are many others, but mostly it's the same mechanism, same concepts of friends each other. So sometimes a group, okay, and sometimes you interact with each other using line or +1, something like that. And you have friends, sometimes friends each other. What is that? It's a graph. Okay? So most of the social media data can be represented by the graph. That is the more complex data structure. Okay? But anyway, we can represent such a social media data using graph data structure. That's one huge benefit. Why? Graph is the example of the data structure in computer science. We have a bunch of algorithms regarding to the graph, like the graph cut, graph search, graph clustering, graph something. So we can use such images in algorithms, or even we can develop such a graph algorithm to process social media data. So that is one of the characteristics of the big data. It's a variety or complexity. It's not static, it's not sometimes streaming or real-time data. It's keep coming the data. So long time ago when we process the static data, for example, so business manager or the something manager, your CEO order ask the IT department to process the data to get the customer, like using CRM, okay? Who will contribute more next year? So using static data. Nowadays, it's based on the real-time data, bunch of coming data, like from the transaction from the branch or social media data, even the news, by combining all of this information, like for example, Walmart, when a customer get into the branch, so if the customer has the RFID card in their server, it's automatically informed to the server. That is kind of the streaming data. Then by analyzing the customer information real time, then even you can display the new advertisement or personalized individual the advertisement, the screen. Okay, we have 10% discount for the textbook course. You realize he attend the new course. For this, how can they know that? Using Facebook. Facebook, you upload. This one I purchased this book or attend this course. That's the possible marketing strategy nowadays. Next, speed. Since we have a huge amount of the data, it will be tough to process. So if that is slow, because of the size of the data, nobody will purchase such as this. It should be fast. So that is the velocity, speed. Okay? So big data that it's not just the size of the data, it should be fast. Almost online data analysis. Okay. For example, e-promotion that I introduced for healthcare monitoring. That's more critical. Like you may get the huge amount of data for individual. Like if we have the sensor in the body, blood pressure and everything, as well as the outside environment, like the temperature, humidity, and everything. Also, how close to the ER center and what is the traffic. Then finally, your system decide this patient is critical condition. You need to go to the Bridgeport hospital using this route, and within 1 minute there will be the ambulance to pick him up. Something like that. So this kind of analysis can be done in this data system. In addition to the 3B, volume, velocity, variety, there is one more thing. It's not actually by the Gartner. So somebody add one more thing. It's a velocity, which means it's a data is uncertainty data. Which means, so traditional data type, traditional data are static data. It's the determined data. Okay, for example. Actually, there were some data analytics kind of without the data system. For example, I'd like to guess who will be the next president. So I'm interested. So how can you guess? You can ask the 1,000 people, okay, by sampling, okay. Let's go. Who will be that? Hillary Clinton or the others? Something like that. Then 55% support Hillary Clinton as the next president. We plus minus 2.5 error margin, something like that. You will see such a poll, right? So this is kind of static. So data analytics using static data. There exists something true, but it's hard to process all the data by sampling. You guess this one, but this is kind of another way to see. Because you cannot see all the data. There are 2 billion of the people in the United States. You cannot ask all the people who you support next president. Then only 1,000 people by sampling. Then you can. But this is based on the static data information. But next, you can check the Google search engine keyword. How many Hillary Clinton? And how many? Who is the House of Representatives? Okay, I should think so. From the GOP. But anyway, some others. Okay? Then check this kind of real-time data. That will be more reliable sometimes. Because people are interested in this one. So every time, real time, you can check the trend of the next president using Google search engine. This is one example. You can use other data sources. This is uncertainty data. But by analyzing, by grouping, by processing, you can get the predict. This is called prediction. So predict. It's not the current data. This one is the actual current data. Since you cannot investigate all entire data set, you can sample. It's a statistic. But this is not just a statistic. This is on top of the statistic. You can predict next trend. So this is Hillary Clinton is increasing. Eventually, the next presidential date, she will be higher than others. Something like that. I'm not a big fan of Hillary Clinton, but it's just so that is a velocity for another week. But this one focuses more in data analysis. Okay. Who generating such a big data? Social media data and networks. So actually the origin of the big data system is from the log information in the system. Log data, system log. If you want to process such a log data, What is the log data? It's a journal data, right? So system keep the record, the current status, or the something, the event. Okay, there's a actually format to like the in your operating system is a printf, right? So time and event context and so on. It's kind of certain format. It's not the very critical format, but it's loosely the made of the format. So, but in addition to that, we have the network data and social media data, also scientific instruments. Like the one of my friends who graduated my old university, he's working for the drill company. So oil company. So this drill is very, very important, critical part of the oil company. So what they are doing is they actually develop the software to show the data. Actually, the data are generated by the drill. Drill has a lot of sensors, speed, and the how much distort and whether how portion of the oil and bunch of the drill information. So that is kind of scientific instrument. I love that mobile device, but because mobile device, so I will have the chance to introduce about the My Life View project by Microsoft. Microsoft, maybe 10 years ago, they initiated the My Life View project. It's simply, what if we record, keep all the data in our daily life, like what I'm talking and what I'm seeing and who I'm interacting with. Why don't we keep all data there? By collecting all the information, including image, video, audio, any kind of the data, and put in the computer, especially Microsoft Windows. So put the kind of data and process and summarize the daily life. Okay. This is kind of ideal for not realistic project. So they actually developed a prototype to keep such a individual daily life information. It's a kind of the digital camera and by some ways, like that. You can find from internet. With project, this kind of camera, and hold this camera and take the photo. The prototype system actually turn on based on light. If you turn, the light is changing, turn on, and the dark is turn on. And keep all the images in the device, and every night it's uploaded to the Microsoft the program. Then that program will, like the MS Explorer, is organized over image, something like that. But it's just an idea because even the imaging, the quality is not so good, and the annotation is not easy. We don't know which image which.
There is no issue for the privacy.
Yeah, but what about the mobile, the smartphone? Smartphone has all the information about myself, right? It has the history of the phone, right? And also take the picture for important the moment, and sometimes the video, texting, and social media, data, everything, even the GPS location. So by analyzing this information, it can be good, or it can be bad. It's like the privacy. So anyway, so this mobile device produces a bunch of data. And sensor technology and networks. For example, several months ago, Amazon, the vice president of Amazon announced that they will use the drone to deliver the package. Okay, so I believe near soon, like within several years, the bunch of millions of drones will fly over the head. But anyway, even though it's not easy to deliver, it will be the real life to use the drone to in our life. So at the time, we can use the drone to get the bunch of information like the temperature, or the sun, the pollution, or the ozone, and bunch of things. So we can collect such a data and process it. This is driving such a big data, actually business point of view. So in business point of view, this is current state, like the business intelligence, including CI, something like that. Complexity is not very complex. We are using relational database or similar data structure to get to process such information. That can be static. Okay, it's not prediction. It's the deterministic. But using big data, you can predict. Even I do not know whether I purchase this one, the company will predict my behavior. Okay, this guy will purchase this product. The chance is 70%. So it's worthwhile to provide, give the 10% discount in advance, something like that. So that is actually such a business requirement. The drive such a big data. So the big portion of the big data in terms of a consumer is the company. Okay? But not only for the industry, but in terms of research, like the academia or the research center is scientific, is a huge opportunity. Problem? If we cannot find any problem in the traditional system, we don't have to worry about it. But definitely to process the big data, we have the problem. Actually, we have the large scale computation computing environment before. What is that? High performance computing, or parallel computing, or other cluster system. Already there exists such a system to process huge amount of data. But there might be problem because of that we have the new system. What can be the problem of traditional system to process big data?
Takes time to process this. Takes more
time.
There is a quantum processing.
Quantum processing.
I do not know much about that. I mean, the consuming time is not a problem.
One of the big problems is very complex.
Yeah.
For example, even though we have the parallel system, parallel motion, if the algorithm is not parallel, you cannot get the full benefit, right? Or even in terms of the programming itself, it's very tough, not easy. That's the reason there is a course for parallel programming. Even though there are middleware like NPI or the some middleware, it's still hard to code and run such a manage such a parallel program. Also, in terms of a system, even though most of the system, the high performance computing, they argue, so their system are tolerable for failure. But it is not true. Which means if a part of the system is failed, entire system is lost. Also, even though you recover the part of the failed system, meanwhile, your system should be stopped. So it's not 100% for the failed tolerable system. So the new system should be tolerable for such a failure. Okay? Also, the traditional system for high performance computing, they focus on the processor power. How much fast to compute the process. So they put the more CPU in the system. So like the SMP and what MPP machine, or so 100 core system, something like that. But in real life, there are more bottlenecks, like the whether you can, what if you have the 10 petabyte data to be processed? Sometimes, even though you have the 10 machines, so you have one big 10 petabyte data, you need to send the data and receive the data. This is a bottleneck. Even though you have very fast interface, bus speed is 100 megabytes per second. Okay? It takes much longer time you expect, even though you have very fast processor CPU. That's the power of the traditional system. So programming search is very difficult. Okay? Even design of such a system is difficult. In other words, a new big system for big data should be easy to manage, easy to configure, easy to program. So that's the value. Okay? Nowadays, it's a data-driven, as we have discussed so far. So bottleneck is the data, not the computations. Okay? So how can we address such a problem? We need to minimize to transfer the data. Definitely we will separate such a big data, but minimize to transfer between the nodes or among the nodes. If we need to transfer the data to other nodes, it will be bottleneck. It will be latency. Okay?
So, Professor, how did big data solve the problem of latency?
So requirement. Then we will see the big data system such as heaven. Okay, so our new system architecture should support partial failure support. That is actually the biggest problem in high performance computing to process big data. So we cannot avoid the failure. Any system can be failed, what damage, what fail. The problem. In case this is a single node system, fail, just nothing. So in high performance computing, parallel system, distributed system, for example, we have a 4 node. They said even though one of them is a fail, your system, entire system is ongoing, but not really true. Meanwhile, while you are recovering system, your entire system sometimes stop, pause. Okay? So the new system due to some partial failure. If the entire system is gone, there's no way, right? But if the partial part of the system is gone or failed, should be recovered. Okay, that's one. The first one. Then data should be recovered, which means even though this one is failed, then the other, using the other system, these data should be recovered. That is the second requirement, and concurrent recovery. So this high performance computing to process the big data has many components. For example, DBMS, it has DBMS, it has the workflow, it has the interface, even though one of them is a fail, okay? The entire system should be running. Okay? It's different from the partial failure. Partial failure is physically part of the system is failed but should be recovered. The concurrent is, for example, DBMS is gone, but still your system is running, okay, and recovered. Data consistency. It's not like the traditional system, but should be reasonable consistency. Okay? It's not perfect, 100% the preserve the data consistency. Think about the Google trend for the next presidential team. Even though we lose little bit data of the search word, so I didn't count 1%, but still data trends are correct. So that's the difference from the traditional system. Yes?
Excuse me, out of these models, this thing is not like clustering
for old system or new system?
No, I mean new system.
New system is cluster actually. But we will discuss. I do not introduce it yet. What is the main thing of the new cluster? But this is a requirement. Okay. And definitely it's scalable. But I need one more. Some performance like this one. At least the linear scalable. But in all the system is actually they argue their system is linearly scalable. So number of nodes. And this is the performance. But in really, the real story is like this. Okay. Goes up overhead. Sometimes not increase even though you put the one because of the complexity. But in the new system, we don't know how much big the data is, right? So should be linearly scalable. So example of the traditional system is based on the cloud computing. That doesn't mean the cloud computing is old-fashioned. Actually, we use the cloud computing for big data system also. But anyway, so cloud computing. So we will have time to discuss about the cloud computing in detail. So 320. Right? We will continue from the, I need to explain a little bit about the cloud computing. Then finally, we will introduce the Hadoop. Okay, this is the major part on Thursday. Okay, and meanwhile, why don't you read? There are a couple of more PDF files. If you go to the first class website, there is the file link of the PDF file for each lecture. Okay, this is today's one. It's already uploaded to the campus. Why don't you go to the campus and the file section? You can download this file as well as two more files. One is the Hadoop IO, another one is the Hadoop ecosystem. Why don't you just go over the slide, okay? Before you come to the classroom. Then you can easily understand my lecture.
It's available now, right?
Yeah, it's available right now.